This video is about a paper titled Layer Level Activation Mechanism, which is published on June 8th of 2023 on arXiv. The usual activation functions that people are familiar with, such as sigmoid, tangent hyperbolic, ReLU, etc., are element-wise operators, meaning that you take the vector of activations of the certain layer in your neural network and you introduce a nonlinearity by applying this element-wise function on it, meaning that the output of these, which is going to be a vector, each element of it is going to be the function, for example, ReLU, applied on that single element and does not depend on the rest of the elements in the activation vector. They propose another activation function, layerAct, which is not element-wise and is also more robust to noise. Consider activation functions that are element-wise, such as ReLU. They propose this scale, which is a function which is increasing between 0 and 1, and it's going to be multiplied by the input and it's going to create the output. For example, if it is ReLU and each element that you're applying this function is larger than 0, this scale is going to be 1, therefore keeping the value of that element. Otherwise, it's going to be 0 and zeroing out that element. Now, this is the element-wise activation. Their methodology, layerAct, works like this. Instead of working directly on this, you include information from the other elements of the activation layer via this layer normalization here. And then you normalize these by the average and the standard deviation. Now you apply this scaling function on this normalized value, which now contains information from the other elements as well. And then you create this scaling value. And then you create the output the same as element-wise by multiplying this scale with the input. The concept of activation fluctuation, which they define here, is going to indicate to what extent the internal representations of the model are sensitive to additive noise on the input side. They demonstrate that this activation performs better in terms of robustness to noise. They also demonstrate that compared to other activations such as ReLU, if you can see here from epoch 1 to epoch 40, the layer activation layers kind of maintain their zero-like means as you go through the different epochs. Also, on the clean classification on CIFAR 10 and CIFAR 100, the noisy version of CIFAR 10 and noisy version of ImageNet, they get competitive performance. You can see that the results are a bit better. And that's it. Thanks for watching.